Hey guys, welcome to RC Video Reviews. Today we're going to talk about inputs and mixers because I think based on the questions that I see, when it comes to actually building configurations in OpenTx, this is probably one of the great mysteries, it seems. It seems like this topic creates more questions and confusion than most other aspects of actually building a configuration. So I thought we'd spend a little time talking about that today, so we can clear it up, so we can spend a little time looking at what they are, what they do, and dispense with some of the nonsense out there and just clear it up. So, Robert, good job, man. You were dedicated today. You're schooling Martin. In fact, I haven't even seen Martin. Maybe he's not playing today. Who knows? So let's see. Doug, welcome. Alan, hello. David, hello. And Stein, welcome to the session. Okay. So, hey, before I get into the topic, I thought I'd show you guys what I've been working on. I'm at a little bit of a stopping point right now because I need quick connectors, but this is my little demo unit that I'll be using when I do OpenTx configurations involving mixes and control channels and things like that. So I've got this little demo airplane put together, and as you can see, it's got flaps and ailerons and elevator and rudder, and it's all working. So these are all articulated surfaces, so we can use these when we're doing demonstrations, so you can get an idea when I do something on the radio, you'll be able to get an idea of what happens on the control surface on the plane. So I've had this request actually a couple of times, and I thought it was just time to try and do something about getting an actual model together that would let us take a look at what's happening on the plane while I'm doing the configurations in OpenTx. And I think I just found a problem, but I'll have to worry about that later. But anyway, it's in work. I'm waiting for a few more parts, and when I get the other parts in, I'll be able to finish this thing off, and we'll be able to do that. Use this as a demonstration tool for future OpenTx like mix type videos. So stay tuned. More on that to come. I've been a printing fool on that thing lately, doing a lot of work printing parts and testing and fitting, and it's been a little adventure, but it's been good. Oh, there's Martin. He's busy taping the right foot toes off. Red Roberts' first entry reportedly kicked a brick wall. Oh, yeah. Yep. Slacking today, Martin. You're a little behind the times. Okay, so I've got the radio set up and ready to go, but before we get into the radio, I want to go over a little bit about inputs. I figure we'll spend some time talking about it first, and then we'll look at the radio itself and look at some of the configuration options to kind of help explain what it is I'm covering here. So I've got my little chalkboard up, and the first thing I'm going to do is pop up this diagram for you. And this is really important. This diagram, I think, and I tried to make it as simple as I can. There's lots of material out there where you can go out and look and find this type of diagram, but I just wanted this diagram to be very, very simple, because I think if you understand the nature of this diagram, then you can understand the nature of information flowing through the radio. So to start out with, we've got the hardware, right? The hardware, when I say hardware, we're talking about the sticks. So on the radio, we've got sticks. Now, when it comes to OpenTx, the most interesting sticks on inputs are the main controls. So aileron, elevator, and rudder. When you build a model configuration, they actually throw throttle in there as well for the input screen, but honestly, I've never done anything with throttle on the input screen. The only thing I've ever really used the input screen for, aside from for some very one-off trick configurations, has been aileron, elevator, and rudder. Okay, so that's where it all starts. It starts with your fingers, right? Your fingers are the input. That's where it all starts. Your fingers, your brain says, hey, finger, move this thing this way. And that's the connection between your brain and the radio. Okay, so that's the hardware, the important hardware when it comes to the inputs and mixer conversation. Okay, the next field after the hardware is the inputs. So in the inputs, they actually used to call this dual rates in OpenTx. So way back when, the input screen, they didn't call it input, they call it dual rates. But the problem was they only had like 4 fields: aileron, elevator, throttle, and rudder, and it caused confusion. So somewhere around 2.0, 2.1, somewhere in there, they upgraded it and called it inputs. And the idea behind calling it inputs was that now you can, while I think about dual rates initially, It really involves anytime you want to offer special treatment, such as curves or weights or expo or differential to an entire input. So an entire bit of hardware like an aileron. So the idea behind defining an input is that you connect the stick right here. You connect that stick to what I call a software construct. And once you've done that, now you can apply changes to that software construct universally. So anywhere, for example, that we have an aileron, and I'll zoom in, don't worry, you don't have to read this right now, but anywhere we have an aileron later on, we can modify all of the ailerons simultaneously if we use the input as the modifying screen. Okay, don't worry, we'll get to that. I'll get to that in more detail in just a little bit. So for me, when I think about inputs on OpenTx, I think about rates, expo, and curves, and any other special functions you want to define. Like, for example, using global variables, and you want to apply global variables to a particular field within a control, like a weight or an expo, you could do that with inputs as well. So any specialized treatment for a given control surface, I think about inputs. Okay. Inputs then feed the mixer. So the mixer, that's the next stage down. If you look at that chart there on the left, what you see is that the inputs feed the mixer. So after we define and connect our stick to a name in the radio, then that information feeds the mixer. The mixer, and the important thing about the mixer, and I probably should have put this in parentheses as well, is that the mixer is where you first create the assignment of the device or the hardware to a channel output on the radio. And that, for people coming from Spectrum or FlySky or anything else, that I think is one of the most confusing aspects of the whole thing, because in OpenTx, we simply don't care about names like aux1, aux2, gear, flaps, aileron, elevator. It doesn't matter. OpenTx doesn't care about those things. What we do in the mixer is we assign the input, the thing, to a channel or a pin number. So that's the big difference between coming from a different radio system and what you see on OpenTx, is that OpenTx doesn't really care about what you call it. To OpenTx, an output is just an output. A channel is just a channel. If you want to hook lights to it, go ahead. You want to hook an aileron to it, go ahead. You want to connect a throttle or ESC to it, go ahead. The radio doesn't care. All the radio knows is, hey, I've got pulse width 998 and I've got pulse width 2012. That's what the radio knows. And it's going to send that out, and the mixer is what connects this stick to a given channel that's identified by a number on your receiver. So those are the two big things that happen in the mixer. You combine your controls. So this is where you're going to do things like combine ailerons and elevators if you have, say, a wing and you need elevons, and it assigns these controls to a physical pin or an output channel on your receiver. Okay, that's what the mixer does. And then finally, you have outputs. Outputs, the mixer then feeds the output tab. And when you look at the radio, and again, I'll cover this in just a moment, but when you look at the radio very closely, what you're going to realize is that they go in order. So first you have inputs, then you have the mix, and then you have the outputs. And they're actually very clever in the iconography of the radio. And I'll show it to you in just a minute in case you've never noticed it. But the outputs is the final adjustment before the information that you have leaves the radio and goes to the receiver, leaves the transmitter and goes to the receiver. So on the output screen, we do things like center the outputs. We've talked about that in prior videos. And you also define upper and lower limits. So if you're used to using something like Betaflight or CleanFlight, for example, and you have to have 1000 on the left and 2000 on the right, the outputs is where you do that. You adjust your output range, your PPUS, your microsecond output range until it matches what Betaflight wants to see, or CleanFlight or iNav wants to see for the upper and lower end. So that's what you do in outputs. And then you can also reverse the output. So if you have a servo that's supposed to go up and it's going down in the output, you can flip that. Okay, I'm gonna stop right here and take a quick pause and read back and see if there's anything I need to address really quickly Robert, I appreciate you being the like whip. Yeah, if you guys don't mind, hit that like button. 45 people watching and only 22 likes. You got to help a brother out. So definitely hit the like button. Tim, hello. Andy, hello. Gary, how are you? Jim, glad you could make it. Ken, and Chris. All right, good. No questions. So we'll move on. I'm going to go ahead and flip over to the radio. So I wanted to make sure this diagram got out there because I want you guys to understand the flow. You go from the stick to the input to the mixer to the output. It's that simple. The job of the input is to connect the stick or the interesting hardware to a software construct so we can do universal actions to that stick. And then the mixer, we combine surface movements and we assign a channel output for that particular device, that stick. And then finally on the output screen, we do things like center our outputs. We provide the upper and lower limits. And if we need to, we reverse servo travel. Okay. So now with that done, I want to go ahead and get into the big camera and go through a couple of different examples so I can show you guys why things are done the way they're done on OpenTx. And I get this one all the time, man. People ask all the time, can I just do this in the mixer? And the answer is sure. You can, there's a lot of things you can just do in the mixer. But let me start out first by doing rates. All right. If anyone's not familiar with what rates are, I'm just going to cover that real quick. And I know for some of you, this is going to be boring, but on the radio right now, I've got an example set up where I have two ailerons assigned to channels 1 and 5. So you can see aileron 1 and aileron 5. They right now have an output pulse width of 2012 microseconds. Okay. So when I move the stick, and the other thing to pay attention to is what this coding means. This little red blob, the red outputs blob, that's the what goes to the receiver. All right, this bar that goes to the receiver. The gray one is what the mixer says. So the mixer says we're going negative 100%, and it just so happens that's also going on the output to the receiver. So the mixer is going negative 100 or negative 100, and then the output for this channel is also 998. So you can see they're both in agreement. And in this case, both ailerons are going in this direction. The output and the stick are both going in this direction. Okay. So now what rates do is they allow us with a flick of a switch to say, well, I don't really want that much travel. I don't want a full 100%. And by the way, this aileron's doing the same thing. Okay. So notice that both ailerons are going this way. It doesn't matter if it's up or down. For this example, it's not material. So watch what happens when I hit the rate switch though. So I'm going to put the rate switch in the middle position. Oh, is it going to make a liar out of me? Aileron. Oh, what did I do? I must have something. Yeah, I see what I did. I was doing some testing earlier and I put a stick configuration in there instead of the input. So see that little icon right there? That means the stick. That means I'm not using the input. So I was doing some testing earlier and I forgot to change it back. I need to change this to my input. That's a good lesson, by the way. Notice that aileron icon right there, you see that round circle with the stick? That's meant to emulate this thing. What that's telling you is that the source for this particular mix line is this stick, not an input. It's a stick. And if we want the input, we have to scroll a little bit and you'll see it changes. So there is the iconography for aileron using the input. And by the way, I said I'd mention that or explain that to you guys in case you've never noticed it before. If you look at the screen on OpenTx, this tab, I'm going to tab left, that's the input tab. So you can see that the little triangle indicates an in, and then there's a mix, and then there's an out, and you can see the control surface. So if you kind of keep that in mind when you're navigating through the radio, you'll pick up on these icons at a later time. You'll say, oh, that's an input, or a stick, not an input. So if you look at it, it kind of goes like this through a mixer and then down through the output. And it actually is a control loop, by the way. From a programming standpoint, they consider this a control loop. So anyway, if you never noticed that before, I thought I'd just point it out. Okay, so we'll go back to my example. I'll put my channel monitor back on. I'm going to put my rates back at 100%, and I'm going to move my stick. Now I've got the stick. I'll go back to where I was, negative 100. Everything's going to the left. Now, if I pull this rate switch down, you notice that this one moved down to 80%. So instead of being at a full 100%, it moved down to 80. That's what rates are. When you hear people talk about dual rates, what they're saying is you're adjusting the amount of throw that the radio sends out to the receiver. So if you're on high rates, this would be an example of a complete up deflection. If I go to mid rates, for example, it doesn't go up quite as high. It maybe only goes to there. This is where that little model is going to come in handy because I can show you this. So instead of being all the way up like that, middle rates at 80%, it's only about like that. And then you can also do low rates if you want. So you can see on this one, I've got 50% assigned for low rates. Okay. So that's what rates do. They change the output. And that's one of the primary functions of the inputs tab. So the input tab, I have a rate set at 100, one at 80, and one at 50. And when I use that switch, the SB switch, mine's named RTE. Don't let that confuse you. It's SB. I did that because I named my hardware in my radio, but it is the SB switch. So when SB is up, I'm at 100% weight. When SB is in the middle position, I'm at 80% weight. And when SB is in the down position, I'm at 50% weight. Now that will apply to the aileron input. That means this stick, okay? So you can see that the input is called aileron. The device that it's connected to is the aileron stick. And you can see that little stick icon with the circle right there. All right. So that's the nature of high and low rates. You also might notice that I didn't do high, medium, and low for elevator and rudder, and that's perfectly fine. In OpenTx, it doesn't care. So you notice that on the elevator, I've only got a high and a low, and then on the rudder, I've only got a high and a low as well. So, and that's fine. OpenTx doesn't matter, it doesn't care. So if you just want to have ailerons only with 3 options, you can set your elevator and rudder to have just 2 by using a configuration on your switches like I have here. So I have my rate switch is up, I'm high. If my rate switch is not up, meaning anything but up, it's low or mid or whatever you want to call it. It's 80%, it's low. So watch what happens to that elevator line when I move my rate switch to the middle position. So I move it down to the middle, and there you go. The low rate is highlighted. Now if I move it down to the bottom position, it doesn't change because the option is anything but up. So, but notice the aileron did change. See, that's the beauty of using inputs. It doesn't matter. OpenTx doesn't care. You just have to be specific about your configuration. So I have aileron high defined with up, aileron mid defined with middle, and aileron low defined with low. And you can see the bold moves from this line to this line to this line, depending on the location of the switch. So there's middle and there's high. Okay. Now, for those of you who might be eagle-eyed, you might have said, hey, wait a minute. I noticed when you were flipping stuff around with your rates, channel 5 didn't go with it. And here's why. The reason why is because this channel 5 on the mixer is assigned to an aileron stick is the source, not the input. So if I scroll back over and make this an aileron source, we should see, let me find it. See if I long click it. I should be able to get inputs. Inputs. There it is, aileron. Okay. All right. So if you're an eagle eye person, you might have noticed, hey, when I was flipping the rate switch, the 5th channel 5 didn't obey. It didn't go along with the rates. It's because I had it on an aileron stick in the mixer. Now, with that said, let's go back to the mixer and look at the truth. Okay. The truth of the matter is in the mixer, you can also change, instead of using an input, you can change this to using the source. So if I click on it and I just move the source, notice how it changes back to the circle with the line through it. Now this mixer is using that stick. Okay. Now I'm going to go back and go down to this guy, channel 5, and do the same thing. And I'm going to set my source to be the stick. All right. Now that I've done that, when I hit model, I'm going to move my aileron stick. And you can see that I've got full deflection left and right. So full deflection. Now I'm going to move my rate switch. Okay, notice that nothing changed on my rate switch. You notice that? The reason it didn't change is because we're not using the input screen. That change is made when I apply those rates. That's done on the input screen right here. So we're adjusting the input. But because in the mixer, we're not using an input, we've ignored that. We're ignoring that. That's no longer a source. Now, because of that, it's ignoring the rate switch. Now, here's the magic question. This is the reason that we use inputs, okay? If you want to do rates, you can do it without using inputs, but here's what you're going to have to do. You're going to have to long press here and hit edit, and you're going to come and leave that one at 100%, okay? And we'll set our expo at, say, 10%, not diff, expo. Okay, so we'll set expo, it's a 10%. Okay, so now we've got our high rates for that aileron. Now we've got to come back down here and do the same thing down here. This is why we use inputs. So now you have to set the expo here, and we'll set that at 10%. Now we know that these two surfaces will behave the same because we've got a weight of 100 and expo of 10. Now, if I want low rates or mid rates, I have to come in here and create another line. Oh, first I have to assign a switch. So let's assign a switch. We'll call this the high rate switch. Let's rate up, right? And oh, by the way, I got to do that on my other control too now. This one has to have a rate switch. So let's put a switch on there. Okay. Now we've got our high rates defined. Now if I want to do mid rates, I have to come in here and do a copy and then a paste. And then we have to edit this one. And we have to set our weight down to something else. We'll set it down to 80. Now we'll set our expo, since we're on mid rates, we'll set our expo up to 22. And we'll set our switch down to RTE middle. Okay, but since we have a second aileron, now we have to go down and duplicate that effort. We have to come down here and do the same thing. So hopefully you start to see the advantage of using the input screen over trying to do this in the mixer. I can take this one and copy it. I can say, let's copy this. We'll do a copy, and then I'll come down here and find the aileron, and I'll paste it in here. And there we go. Now we've got a paste. Now if I watch my monitor screen, I can flick my switches around and I can see that I've got rates, just like when I was using the mixer. Now can you imagine what would happen if I added another function into this, like an elevon mix? And I wanted high rates and low rates for an elevon. Hopefully you can start to see where this is going to create a problem, right? So if I had, and what if I wanted to have a mix on my elevator as well? So you see, you can start to see the nature of the issue, right? Now, if I want to do low rates, I have to copy this guy and paste it and then adjust it. And then, by the way, anytime I change one of these rates, let's say I'm flying around and I have my low rate set on 61, and then later decide I don't like that, I have to adjust that number here and here. And if you forget to do that, you're really going to create some problems for yourself in the plane. So hopefully you guys can see why we use inputs for dual rates. I mean, again, this is one of those massive, I get this question all the time. Why do I have to use inputs? Well, you don't have to. You can do whatever you want. That's the thing about OpenTx. You can do it however you want. But the thing to understand is if you don't try and, like embrace the way they've designed the system and utilize it that way, then you wind up with a hot mess. And by the way, I haven't even done a mix yet. I haven't even done a mix. All right. So that's the nature of using inputs versus the mixer for things like rates. Okay, let's clean some of this up. I want to get rid of all this nasty. That's kind of ugly. Let's see. Okay. Now I want to show you another example. That pretty much covers the rates, and that's why we use the input screen to define our high rates, mid rates, and low rates. You don't have to have high, mid, low. In fact, you don't even have to have high, mid, low. You can just have high. You can just have a single rate if you want to. That's another thing that I get all the time is that people say, oh, OpenTx is so hard. Well, why do you say that? Well, because you have to have high, medium, and low. You don't, though. You don't have to have high, medium, and low. You could just have high. You could just have one rate and that's it, if that's what you wanted. And if you only had one, you wouldn't even need the input screen at all. But if you do want to use things like dual rates, the best place to put them is in the input screen. Okay. Now, the next thing I want to talk about is I want to give you an example of flaps. Okay. So in my flaps, I've assigned my flaps to my left curve, my left switch, my left slider here. So you can see I'm moving my left slider up and down. When my flaps are up, you get the flaps are closed right here at the 0 position. And then when I want them at the midpoint, they're right here at about 15. No, it's about 22. Is that what it is? About 22. And then when I go all the way down, they're at about 65. Okay. Now, here's another reason that you use inputs. Like let's say we go back into our mixer, and in our mixer, I've got my flaps assigned right here on channel 6 and channel 7. So if I use the hardware interface for channel 6 and channel 7, meaning the left slider, then anytime I make adjustments to one, I have to make an adjustment to the other. So for example, if I'm using two, like say you have a glider that you're going to have set up and you want to do crow braking for that, in that case, you would put flaps on two different channels, right? You'd put flaps, one flap on 6 and one flap on 7. But if you decided that you wanted to apply a curve, you would have to apply, you can see on channel 6 and 7, I've got that same flap curve that I used on my input, but I've only applied it to this one. So now I have to go apply it to this one as well. So however you decide to use flaps during your configuration, if you make a special change like a curve, you have to make it to both interfaces or you're going to wind up with an out of balance airplane. Now, if we were to clean this up and do it the right way, we can go in and say, okay, for channel 6, we'll just edit this and we'll make the source, it's an input. So we'll make the source, and I do have a flap input, so we'll make it flaps. And we'll take that curve off too, because we don't want to have the curve applied twice. I've never tested what'll happen, but I can't imagine it would be good. So we'll just take it off. And then on channel 7, we'll do the same thing. We're going to, oops, that's okay. I deleted it. That's all right. We'll just copy this one. We'll copy 6, copy, and we'll just paste that into 7. And then we'll just name this one flap 2. Okay, so now instead of using my left slider as the source, I'm using my flap input as the source. So now if I come over to my input side, my flap, notice I've got the left slider as the hardware. The interesting bit is the hardware is the left slider. Now I can come into this input and I can say, well, I want to use the custom curve called flaps. And you see how that curve works like this. And if I decide, well, I'm going to change that and I want to use, instead of 65, I want to set it to 51. Now, when I go back, that curve is applied via the input. It's applied to both of the flaps at the same time. So if I press the model button and I operate my flap switch, you can see that both flaps on channel 6 and 7 are behaving the same. Now, in full disclosure, if you assign that same curve to the inputs on both of these, it would also do the same thing. But just remember, you have to make sure that these two control surfaces, both of these channels, these flap channels, have the same curve applied. If they don't have the same curve applied, you'll wind up asymmetrical. Okay? Now, that's inputs and mixes. That's pretty much the best example that I can give you guys on why you separate things out and why you use inputs and mixes. The last thing we'll do is we'll take a look at the outputs. So on the outputs, oh no, let me change my aileron back to the source, the input rather. There we go. Okay, so if we look at the monitor and we say, okay, I've got left, I've got right, everything is copacetic there. Now, let's say that in beta flight, I'll bring this monitor back up. Let's say that in beta flight, I'm putting out 2012 microseconds and I only want 2000. Well, the place to deal with that is in outputs. So if we go into outputs and look at channel 1, you can see the output monitor right there shows 2012. So if we go to channel 1 and click the jog dial and go to the output side, and we lower the max. Notice the output, the microseconds output is lowering on the output screen. You see it? It's down to 2008 now. Now it's 2005 and 2001, and there's 2000. Okay? So now when I come all the way to the right, I have a limit of 2000 microseconds. Now, if we have to do the same thing for the bottom of the range, when I go all the way to the left, notice I'm at 988. Well, my open flight and clean flight, sorry, open flight, is that a thing? Clean flight, beta flight, they all want to see 1000 as the floor. So all we have to do is go there and we move the floor up to 1000. There we go. So remember earlier in the video, I'm going to scroll back to that screen real quick so you can see it. I said that the outputs let us center our outputs, and they set the limits for the min and max. Okay, that's what I mean by the limits. You can change the output limits going out of the radio with that function I just showed you. Okay, now the last thing we'll do is, let's say that on channel 1, when I'm moving the stick this way, that output, the red bar, it's going to the right, but it really should be going to the left. Well, outputs is where you change that too. Most people would call that servo reversing, and that's really what you're doing. You're changing the direction. So we'll go to channel 1, and you see this little arrow here. I'm just going to highlight that, put a check, push down on the jog dial there, and now when we bring up our channel monitor, watch, there's two things that happen. Notice this little curved arrow right here. That's telling you that that one's reversed. So that wasn't there before. So that's the first thing that you'll notice. The second thing is that the mixer still goes to the right. You see how the mixer is still going to the right, and the mixer is going to the right on channel 5, but now the output's going to the left. That's a channel that's been reversed. Now look at our outputs though, they still apply. I still have 1000 as an output, and I've got 2000 as an output going this way. So there's the nature of flipping a servo. And then regarding center, I actually have a whole video on this. We did trims versus sub trims. I'm not going to go into the specifics of that here because I do actually have a full video on that. But if you need to change your center position, notice that right here, if we have it at 0, notice that the output center on, well, look at that. It needs a 0.2, but to get it centered at 1500, you need it at, on this particular setup right now, you need it at 0.2. So if you want your radio to output 1500 microseconds at center, here's where you can make that adjustment. And that's also known as sub trim. Again, I'm not going to go into the full specifics of sub trim versus trim here because I have a video on that. And in fact, I just did it a few days ago. So you want to look for that. It's an OpenTx snippet. And we go into great detail about the difference between trim and sub trim. But anyway, there's how you arrange the center point for your servo. So if you're not happy with your center point, you can use this field to adjust the center point of your servo. And when you do that, you don't lose the overall range. The overall range is still in place. The 1000 to 2000, that's still intact. But what will happen is your center point now is moved in that arc. So when this side of the travel will be lower, this side of the travel will be higher. You'll have more movement on one side of the arc than you will on the other. That's the thing to take away from it. Okay, that's inputs, mixes, and outputs. And then I think on mixes, there's one thing I want to cover. I kind of skipped over it real quick, but in mixes, because we talk about the idea of combining surfaces, and I did have something I wanted to show you on that, and that was my elevator to flat mix. This is one of the questions I get all the time about mixing. Regardless of how many mix videos I put out, somebody always comes up with a new mix. The thing I want to tell you about mixing is you always want to look at the surface that needs to be corrected by the surface that's going to do the correcting or that's causing the issue. So in my case, if I deploy my flaps, the elevator needs to be corrected. Okay, when you deploy flaps, a lot of people say, well, when I deploy flaps, I want my elevator to pitch down so that I don't get that ballooning effect with my plane. So the way we do that is we look at the surface that needs to be adjusted. That's in this case the elevator, and we're going to add a slight mix for flaps. So if you look at channel 2, I'm going to bring up my channel monitor and I'm going to operate my elevator first. So you can see when I pitch the nose down, my output goes this way. Okay, for elevator, it goes this way, goes to the right. Okay, now you guys remember my flaps are over here on the left hand side. If I deploy my flaps, right now my flaps are neutral. You can see on channels 6 and 7, the flaps are neutral. But if I deploy my flaps, look what happens to the elevator. So I'm pulling my flaps down and I'm getting a slight, only 12 or 13% nose down. You see that? Nose down. If I nose down, the output goes this direction. That's a mix. The idea is we're taking two different surfaces and we're combining them to have an impact on one. So in this case, I'm using my flaps to have an influence on my elevator. So in this case, when I deploy flaps, I want my nose to go down just a little bit. So I'll let you look at that configuration in the mixer again. The elevator is real simple. That's the normal standard mix line for an elevator. But the second line that I added, and I'll show you how to do it in case you've never done it before. I'm just going to delete this. I'll delete it. Delete. Now I'll just add another one. So I'm just going to highlight my elevator line right here. I'm going to press the jog dial. I'm going to hit insert after. And notice how, well, you'll notice it when we go back to the thing. And I'm just going to call this FL for short. You guys know that that's the flat mixer. There, flat mixer. And then for the source, we want to use our inputs, and we'll use our flap input. And for the weight, just a little bit. We don't want a whole, like if I left that at 100 and I deployed flaps, that would give me 100% nose down on the elevator. We don't want to do that. So just a little touch, right? Just a little touch. We'll move it down to say 10%. Okay, that's it. So we escape out of that. And now again, when I deploy my flaps, you'll see, oops, it's going the wrong way. Oops, how do we fix that? Well, that's easy. We just invert this weight. So if your control surface is going the wrong way on your mix, just invert it. So instead of being 10, we'll set it to -10. Okay, so there's a -10. We'll hit escape, press the model button. Now we deploy flaps, and you can see here. You can see that I've got that 5% nose down, just a little bit of nose down. That's it, just a touch. That's a mix. So when you hear people talk about mixing, that's what they're talking about. They're just talking about mixing. That's it. It's just taking two surfaces so that they work together. So now if I deploy my flaps from now on, I'll get a little bit of movement on my elevators to help avoid that ballooning impact. All right, let me see. I'm going to go back and check. Like button done, like. You can really confuse yourself if channel 1 uses stick, but channel 5 uses input. Yeah, Dave, absolutely 100% correct. That's probably the worst case scenario. If you use on your mixer, if you start mixing up the two and you have, for one, that's what I had earlier. I was using the stick itself as the source of my mixer, and then on the other one I was using, oh, there it is right there. See, this one uses the input, that one uses the stick. That's like the worst case scenario. That's the worst thing you can do to yourself. Oh, let's see. You do this same process. Chris McCallum says you do the same process whether you're an input or the mixer. However, you do the simple stuff like rates and expo in the input screen. It then leaves room for special operations to make. Yeah, that's true too. So what he's pointing out there is that you notice in the mixer, you have the same options in here for things like curves. So if you want to apply an expo, you can. If you want a function, you can do that. If you want to add a custom curve, you can do that. And then differential. And then isn't offset in here too? I thought offset was in here. Where is that? Did I lose offset? Oh, it's right above it, right there. There's offset. I wonder why that's not in the same line. Maybe because they could. I don't know. But anyway, yeah, that's true. So if you use inputs for things like rates and expo, that saves this field on the mixer for other things like, say, differential, for example, or a custom function. So yes, very true, Chris. Inputs, a hot mess avoidance tactic. Absolutely, Jim. The idea, I think the key takeaway on inputs that you want to think about is that when you use inputs, you can apply a modification to the surface before it ever goes to the mixer. That's really the kind of the key. And yeah, if you start trying to apply those modifications in the mixer, especially if you actually have mixes set up, man, it can turn into a real hot mess real fast. B-Hups Mats, hello from London, enjoying the video as always. Awesome, man. Thanks for joining. I appreciate that. William Cox, how are you? Sam Burns, maybe a stupid question, but for simple aux switches, do you have to set in inputs? No, Sam, that's not a stupid question. That's a friggin' awesome question. And that's the exact question that I had in mind when I said the most interesting hardware are the primary control surfaces, AER. So with that said, you can put whatever you want in the inputs. If you can do whatever you want, you can change, you can add switches to the mixer. You can add knobs to the mixer. In fact, if you add your S1 and 2 knobs, say you have gear and flaps and you both want them to operate under 50%, you can put a curve together, put them in the input screen, and then add that curve to both in the inputs. And that way, whenever you use them in the mixer, they both use the same curve. That's why I said exactly what I said here. It's the most interesting hardware are the primary control surfaces, but you can put whatever you want in the mixer. But here's the main thing. For most of what you're going to do in OpenTx, you only really kind of need the three. The aileron, elevator, rudder. They, like I said in the beginning, they put throttle in there, but you really, I mean, who does dual rate on throttle? I don't. You might want to put expo on throttle, maybe like if you're flying a quad and you want the center to be soft, or say you're getting ready to take off and you don't want it to be too jumpy when you pull out of the chock. So you might want to soften the bottom a little bit. But yeah, other than that, you really don't need to have the throttle in the input screen. It doesn't need to be done. So not a stupid question. I get that question all the time. All right, Ray Gehring, can't get my UMX models to work in my T12 Pro. I'm new to OpenTx. Ray, you should hop on Discord. Someone should be able to help you there. I'm not a UMX / Spectrum / Horizon expert, so I have no UMX plane, so I don't really have any experience to offer, but I'm sure someone there can help you. Chris says, just assign any switch to whatever function you like, but it doesn't need its own input. That's correct. Inputs are really think about inputs for things like rates. That's the one that I want to, I'm not saying that's the only one. I'm just saying, to me, that's the primary use of inputs, is for rates and curves and functions. And there will be times when you're going to want to do stuff like that. Believe me, it'll happen. But I'm talking about for most basic configurations, most 4-channel airplanes where you have something like dual or triple rates, then the input screen is really, that's where you do things like dual rates or triple rates. That's the main objective. Okay. So the answer to your question directly, Sam, is no, you absolutely do not need to put everything in inputs. In fact, I'd argue against it. The only thing you should put in inputs, in my mind, until you really know what you're doing, are things that you want to have dual rates for. That's it. Or special functions for. Okay. All right. Friedel XT, I don't have this round stick icon. Is it special for TX16? They have all the icons throughout OpenTx, for as far as I can remember, all had discrete icons depending on what you were using, inputs or sticks or hardware. So in Tyrannus, I don't have a Tyrannus in front of me right now. The icon might be slightly different, but I can assure you that when you look at these, when you look at these sources, let's edit this one and we'll look at it. When you look at the source list, in fact, if you long press it, you get an option that says sticks, pots, max, trims, switches, trainer, channel. So let's just say sticks. So if we highlight sticks, you can see that circle with the rod coming out. That's a stick. If you long press it again, you can do pots and it'll show you I named my volume. It also considers the 6th position a pot, obviously, and an S2 is a pot. So they're there. Trust me. They're in OpenTx. It's always been that way. So which simulator should I get to learn to fly RC helis? You need to get on Discord and talk with Freddie. Freddie's your guy on RC helis. He'll be able to help you out. Mr. Epic. I'm not a heli guy, so I don't have a great answer for you there. Crypt Keeper, do you recommend adding a little rudder with the elevator and flaps to counteract the torque of the motor accelerating during takeoff? Crypt Keeper, for me, no. Those that know me and have been around the channel for a while know that I don't like mixes at all. The only reason I even really talk about mixes is for people who ask. Personally, when I learned to fly real airplanes, my instructor said, fly the plane. So I just kind of fly the plane. The only thing I really use along this vein is trim. So I tend to avoid mixes. Now, I'm not saying I've never done it. I've done things like differential thrust just to goof around, to play with it a little bit, because that's kind of cool. I have done a little bit of work messing around with rudder and aileron mixing for knife edge flight. So if I go into a knife edge, I've done a little goofing around with rudder and aileron to change coupling behavior during knife edge. But predominantly for me, no, I don't like mixes. I don't use them. One of the big ones I get asked all the time is the flaps to elevator. And, again, I don't do it, but I show people how. And then I guess to be fair, I obviously use mixes for things like wings, but that's different. You know, you have to mix or your plane won't fly. So, all right. Are there any drawbacks to use logical switch in the mixes? No, I mean, no. If you know what you're doing, you can use logical switches in a mix to turn things on and off. So here's an example. Here's an example where you might use something like that. That's a good question. Let me go through that one. Who asked that question? Where did it go? Bjarn Lindqvist. Lindqvist? I'm going to show you a good example on that one. Here's one right here. So elevator and flap, okay? Let's say that we want this to only go on. That's a really good one. Let's do that one. So let's say we got our elevator flap mix, and you guys remember when I put my flaps down, I get a little bit of elevator input, okay? So let's say that for argument's sake, don't argue with me about aerodynamics, just roll with it, okay? Let's just say for argument's sake that we want to say when our throttle is less than, we'll call it throttle, is less than, we'll call it, I don't know, let's call it 50. That's about 75%. You're down there. So when your throttle is kind of low, we want L01 to be on. And you can see L01 is on now because my throttle is kind of low. But as I bring my throttle up, L01 is off. Okay? So what I'm going to do is I'm going to say, we're going to assign L01 to say, when my throttle is advanced, I don't really care about the elevator flap mix. If I'm using flaps, and I might be doing it for an aerobatic maneuver, for example. So L01 doesn't go on when the throttle is above about 75%. When I bring the throttle down below 75%, you see how L01 goes on. Now we can go back and take that L01 and put it in our mix line. So this mix line now, I'm just going to add L01. We'll just come down here to this switch. I'll long press it, and we want logical switches, and we'll use L01. Okay, so you can see L01 now is bold. When I go up like that, it's off. So when I look at my monitor now, let me get out of here. I'll click on my monitor now. Look what happens when I move my flaps. You see how the elevator is not getting any input at all? There's no change because I'm gunning it. My throttle's up high, and I know when my throttle's up high, I don't need to worry about ballooning. However, watch what happens when I bring my throttle below. Are we locked? Something's going on with my throttle. There's the problem. I deleted the throttle from the mix. That's why. Okay. See this? There we go. Okay. So now my flaps are all the way down. When my throttle, there it worked. So here, let's go back, reset everything. Flaps are up right now. Okay. Throttle's at 100%, and I'm going to bring the flaps down. Notice that there's no change to the elevator. Now, if I slow the plane down, slow it down, slow it down, slow it down, and I get down to about 70% mark, watch the elevator. You see how it just kicked into that 5%? That's an example of using a logical switch for a mix. And you might, there's 100 different ways you could do that. So the answer to your question is you can absolutely use logical switches in your mixer. No problem. Okay. Sam, you're welcome for answering your question. Could I watch this afterwards again completely? Thanks for your awesome videos. Egon, yeah, this will post. It'll be on the channel. You just go on the RC Video Reviews homepage on YouTube and look for the live stream stuff, and you'll see it. One more question. Can you set trim switches as momentary switch? Sam, I actually did a video on this, but I'll show you how to do that real quick. You go into special functions, and we'll do, I'll click on this. I'll press up on T5. It's not highlighting for some reason. There it is. There's 5 up. Okay, and we'll just have it play a sound, beep 3. Okay, so there you go. Press 5 up. You see that? I'll press 5 up and you'll see it go bold. And it's beeping. You get it? So yeah, you can absolutely use these trim switches as momentary switches. In fact, I did one where it's the lasers B hack. I think you can go up and down and in. And so you get 3 different momentary switches on every trim switch. The only thing is you want to make sure you go into your flight modes right here and turn off. You want to go in here and turn off T5, because if you don't, you'll eventually run into the bottom. And every time you click that, you'll get a audible prompt from OpenTx saying trim maximum, trim maximum. It's kind of annoying. So just turn it off in flight modes. All right, throttle curves are beneficial for helis to compensate for collective. Yeah, helis and quads. Yeah, there are areas where curves can be beneficial, and if you know what they are, then sure, you use inputs and curves and apply them as appropriate. No question about it. All right. Throttle curves, which could I watch as average? Yep, you're right. Only tried to move the stick for choose. Okay. One more question. Can you set? Yep, covered that one. If you have a question, yeah, that would help if you guys prefix your questions with a question mark. That helps me scroll through quickly. Okay. Sorry, guys. I'm scrolling, looking for questions. Any drawback, safety? No. Logical switches, no. There's no drawback to using logical switches. As long as you understand the logic. If your logic's wrong, then you can create a problem. I mean, it's pretty easy to say that's down. You know, in a logical switch, you have to know what would cause that switch to go active. I know in my case what causes it to go active, and that's when my throttle is below 75%. So I know when it's below 75%, L01 is going to go live. So no, I don't have any... Look, man, if you're going to worry about the software not working, then don't fly the radio. But if you understand the logic and say, I know that when this goes below 50%, 75% or negative 50 on the scale of 100 to negative 100, that L01 goes on, then every single time that will go on. I've never had a logical switch fail to go on when I knew the logic. Okay. So no, I don't have any safety concerns relying on logical switches. In fact, most of my configurations rely heavily on logical switches. All right, thanks. Thinking buying this is my first transmitter. Been practicing on real flight for a long time. Finally ready to get in the hobby. Been in there. Well, you won't go wrong with a OpenTx radio. I can tell you that. The biggest problem you have with OpenTx is getting support at the field. A lot of AMA fields. The people there are Spectrum people, and that's fine. Nothing wrong with that. But if you want to use OpenTx and AMA field, you're going to mostly be on your own. Now, if you're not flying in an AMA field, then who cares? Doesn't matter. And yeah, welcome to the hobby. Good call, Chris. Really considering the max for the IPS panel. Yeah, except for like the low end one, they're all IPS panels. And the gimbals are cool. The CNC is definitely cool. Absolutely. Akash Jana says, I'm waiting for OpenTx 2.4 to show off touchscreen in the field. Yeah, I think a lot of people are looking forward to that one. No question about it. 2.4, if you don't, by the way, if you need to know, if you have a touch panel, go into your hardware screen and go down to the bottom and let's see, go to analogs, and then you see where it says touch panel. When you touch that screen, you should see a couple digits pop up. If you see digits pop up, you've got a touch panel. If you don't see those digits pop up, you don't. Hey, there's still 63 people live and 51 likes, guys. You help the channel out when you interact with the video, so I'd appreciate it if you guys could go ahead and hit that like button. Let me know, or hit the dislike button. But either way, do something. Help out. It helps the video placement when you guys interact with a video. So definitely make sure to interact and hit that like button. All right. Yarn Linkfist says perfect answer. Thanks. You're welcome. Yeah, you're welcome. Yeah, don't worry about using logical switches, man. I've got them all over the place. I use them on everything. 2.4 needs to have a way to lock out the touchscreen to prevent accidental changes. Yeah, I imagine, Dave, that they probably will have like an option to use it or not. My guess is OpenTx developers are really smart guys, so you don't have to worry too much about them. They'll do it right. I'm confident. And by the way, if you don't want to use the touchscreen, then don't upgrade to 2.4. Jim says, can OpenTx access and use the 2 UARTs at the bottom of the ARM TX? Can OpenTx access and use? I don't know, Jim. I don't know if anything is set up to use them at this point. And probably, I don't think it's going to be OpenTx specifically. I get the feeling it's probably going to be something like a Lua script that would access those. Jim's referring to these 2 pinouts down here at the bottom. You got that UART and that UART. That's what he's referring to. So, I imagine that OpenTx really probably doesn't care. I think it's probably Lua. They're there. I'm sure they're addressable. All right, let's see. Difficult to say. Some people say HeliX is more realistic, is much cheaper. B-Stern, what up, guys? All right. All right. Well, hey, listen, that has been, we are right at an hour right now. So I'm not seeing any additional questions. There's a demo checkout. Okay, we're talking about the flight simulator still, the heli flight simulator. Yep. So I'm not seeing any additional questions. All I can say is keep an eye out for my little demo plane. That thing, I really kind of wanted it for today's video. I worked hard to get it. You can see that I threaded all my control surfaces on and everything's ready. I just don't have enough quick connects. I need too many of them. I don't have enough quick connects handy. So I'll have to wait till they show up in the mail. But they'll be here soon. And when they do, I'll get this little plane put together and then we'll be able to do examples with the radio. I can zoom out a little bit on the camera and we can use this as our little demo device when we're looking at stuff. Be stern, no worries, man. You can catch the replay. It'll post not too long. Oh, let's see. I'm confused by offset. Does your sub trim video show the difference between sub trim and offset? No, Alan, it just does trim and sub trim. And the reality is that offset is basically, it behaves the same as sub trim. So I've actually been thinking about doing a video on that one, but offset just moves center again. I'll have to look and see regarding the outputs. I'm not sure. Let's take a look. Let's see. We can take a look. I'll go in the aileron and I'll add a little bit of offset. So I'll just add, I don't know, 25% offset. And now we'll look at the monitor. Okay. So you notice that the mixer, yeah, this is normal. So no, offset looks just like trim. It looks like it behaves just like trim. So what you're seeing here is with offset, you can see that the output has moved over 25%. Okay. If you didn't catch that, let me go back. Oh shoot. I'm getting click happy here. All right. I'm going to go back and set this all back down to 0. So you can see. Okay. So we're looking at channel 1. Okay. Right now I've got channel 1 at 1%. I can get rid of that by going into this and changing the sub trim back to 0. Okay, so we're at 0, okay? We're at 0 and for some reason only 98% throw. That's because I adjusted the upper limit, which is fine. We'll leave it at that. So 100 in the mixer and 98% on the output, okay? So now if I go in and add into the mixer, if I go in and add an offset, so let's just take an offset of 25 just to make it obvious and press the model. Well, the first thing you can see is that we already have an output change of 25%. That's the first thing. So you've moved that surface, right? It's moved 25%. Now, if I move the stick all the way, notice that the stick still stops at 98, but the mixer went to 125. Do you notice that? So look at what's happening here. The two reach the extreme at 100%. So look at this. Watch this. So we're going to hit 102% here and 98 there. But I still have movement on the stick. See what I mean? I can still move the stick. Let me move it down so you can see. When I'm at 100%, I can still move the stick that far and I'm not getting any movement on the servo. So when I go the other direction, I lose 25% of my throw and the stick stops moving at 75%. So that's as far as I can go. So offset, you definitely lose travel off one side and you gain stick movement on the other. So that one's kind of kludgy, to be honest with you. I'd rather use sub trim or trim rather than offset if I could avoid it. All right. Yeah, this is great. I figure if I hear and see it another 10 times, I might even understand it. Well, you know, Jim, now the video is up there, so you can watch it a few more times. And yeah, the plane's pretty cool, man. It's getting there. It's getting there. Almost there. Like I said, I just need some quick connects. I also realized, I don't know how I did it, but this aileron's wrong. That control horn's supposed to be here. So I don't know what I did. I've printed so many copies of these things at this point. I probably just mistaken one. So that has to come off and has to be replaced. That control horn needs to be over here, but I'll get it worked out. No big deal. All right, fellas. Hey, listen, I'm not seeing any more questions. So I think, yeah, B Stern says it needs a motor. Yeah, there's been questions in Discord on whether or not it'll fly. I'm pretty sure it would. Probably need a stabilizer to help keep it straight, and obviously a motor, but that's it. Alan Lowe says, hi, how to set a function 3mm light can flash. Thanks. I don't understand that question. I don't understand that one, Alan. Kelly Takai says, just got my radio. Good info. You're welcome. This is really good format, John. I like this one a lot. Okay, cool. I'm glad you like it, Bjorn. Bjorn, I hope I'm not butchering that too bad. Alan C, great job. Thank you. For the distant future, you may want to take a look at discus launch gliders. Plenty of good OpenTx material in use over there. Yeah. Every gliders seem to have more of the complex OpenTx configurations, don't they? I did that crow breaking snippet, and that was one of the more complex designs. So. All right, guys. Well, hey, that's it. That's a wrap for me. I appreciate you guys joining. I appreciate all the good questions. So make sure you leave a thumbs up. And if you're not subscribed to the channel, subscribe, hit the notification bell. Make sure you interact with the video somehow. I appreciate that. Before I go, Pete says, is it possible to see your radio setting changes by way of flying a plane on a simulator? No, I mean, yeah, I guess. I mean, if you do a mix, it's going to manifest itself. If you have those channels set up on your simulator airplane, then whatever changes you make are going to manifest itself in the simulator. The problem is I don't know how granular it's going to be. That's the problem. So Jim says, when do we hit 10K? I'm still thinking it's going to be last week in February, Jim, at this point. Hard to tell exactly, but it's definitely looking like end of February. Last week, maybe end of the last week of February. We are, by tomorrow morning, we should be around 9,500. So 500 more to go. All right, guys, that's it. I'm going to call that a wrap. I appreciate you guys attending and asking the good questions. So you all take it easy. Hope you enjoyed the video. That's all I've got for today. Take it easy.